This is Ranger Kidwell Ross, editor of WorldSweeper.com and the director of the World Sweeping Association. With me, you see Roger Sutherland, who's the principal of Cascade Water Resources in Oregon. And we were the two co-developers of the test for microplastics that was conducted in July of 2025, the first test in 14 years done on a national level for different varieties of street sweepers. And you're going to learn all about that as we go. So we'll start with our presentation and show you exactly what we did and how we did it. So Roger will be presenting this first part.
All
And
right. Okay. Thank you so much, Ranger. First off, there's the title of our presentation, and there's information Ranger just shared with you. I want to start off first by acknowledging the project in which this work was done and therefore funded. Um, uh, 3 years ago, the city of Santa Barbara wrote a proposal to NOAA and was successful, got a sea grant. And part of the whole objective of that proposal was to look at innovating public works practices to intercept microplastics. In other words, what public works practices do we currently do that can be successful in intercepting microplastics? So you can see there's quite a few people that are involved in this project. Jill Murray at the city of Santa Barbara wrote the proposal. She reached out to me and I brought Ranger in. So in terms of the objective two, which is shown there on the right, we want to optimize street sweeper pickup efficiency for the intersection of microplastics. Now, the city of Santa Barbara is working with us along with the University of California at Santa Barbara, and of course, Ranger and myself. So, when we first were successful in winning this project, Ranger and I talked for a little bit and we realized we really didn't know very much about plastics. I mean, many people, they've heard there's a concern about plastics, they've heard there's accumulations of plastic in the ocean, but we really didn't have much information. So, Ranger, being the journalist that he is, decided, well, I'm going to research this and I'm going to write an article. And he did that. And it's about 2 years ago. And, here's what he found, some of the highlights from that article I've placed here. And, humans have produced more than 8 billion tons of plastic since 1950. I was the year I was born. And more than half of that has gone straight to landfills, but only 9% was recycled. And you see, plastics are a problem not only because of the toxins they contain and throughout their manufacture, but also the fact that they can be ingested by aquatic life and create all kinds of issues. And what's really interesting is it should be noted the US produces more plastic waste. And according to the data 216, as you can see, we produced over 34 million tons, followed by India and China. And there's a nice graphic of what the plastic looks like floating in the ocean. So, there is not only a plastic problem, but the world has a plastic pollution crisis. And most studies report that people eat or drink an estimated 73 to 52,000, no, excuse me, 39 to 52,000 microplastic particles every year. And if we put inhalation in the ball game, then that goes up dramatically, as you can see. And to me, of all the things I've listed here on the bullets, and I'm not going to go through each one of these, to me, that first one is like just very difficult for me to wrap my head around. But I do want to read you the quote at the bottom from the Center of Biological Diversity, talking about our ocean plastic pollution problem. A global tragedy for our oceans and sea life. Plastic accumulating in our oceans and our beaches has become a global crisis. Billions of pounds of plastic can be found in swirling convergences that make up about 40% of the ocean's world's ocean surfaces. And at current rates, and this is just unbelievable, plastic is expected to outweigh all the fish in the sea by 2050. So the next thing we need to do is ask ourselves the question, okay, what can be done about this? And, street sweeping studies over the past 2 decades have targeted a variety of pollutants found in our waterways, including nutrients, heavy metals, and toxics. And we now have data that suggests that we're doing an excellent job of all of these things. And we have known since 1972 that the primary source of pollution in stormwater is contaminated street dirt that accumulates on urban streets and parking lots and easily transported to waterways by urban runoff. Based on the work that has been done by so many, and most recently by the University of California at Santa Barbara, we know that sampled street dirt worldwide is contaminated with plastics. And the most damage potentially that can be done, of course, are the smaller particles of this plastic, where we get the term microplastics. In fact, microplastics are defined as small plastic pieces less than 5 meters long. And this is the size, of course, most harmful to ocean and aquatic life. So the study that we're about to describe is the first study in the world designed to evaluate how street sweeping removes microplastics and nanoplastics, which are smaller versions of the same, that have been scientifically placed within a street dirt simulant that mimics the physical characteristics that are found in real street dirt. So before I get into the study, I just want to back up a bit. Ranger and I, we've done 2 other presentations at this event. This is our third presentation. Now I want to refer back to the first one that we did in September of 2023. I want everyone in the audience to understand that as far as I'm concerned, as far as the science concerned, it's clear now. It hasn't been clear for 50 years, but it's clear that America's first line of defense for stormwater pollution abatement is street sweeping. Now, let's go way back 45 years ago when the nationwide urban runoff program, NERP they call it, started in the early 1980s. I was involved in 2 of those. And they wanted to study, it's EPA funded, about $30 million. They wanted to study the effectiveness of various BMPs throughout the country to abate stormwater pollution. And street sweeping was included. And the way that they did that is they wanted to look at whether or not it could reduce the event mean concentration for 5 pollutants of interest listed there at 10 locations in 4 states, North Carolina, Illinois, Washington, and Wisconsin. But it was the unexplainable negative results from 2 sites in North Carolina and 1 in Wisconsin that result in the conclusion, and I quote, street sweeping is generally ineffective as a technique for improving the quality of urban runoff. They reached this conclusion despite the fact that the data clearly showed EMC decreases in 34 of the 50 site pollutant investigations. So it's been statistically indeterminate results that have hampered sweeping's perceived BMP value for stormwater runoff pollution ever since. Let's fast forward to 2010 with the city of San Diego's targeted street sweeping pilot study. And they decided as part of this project that they were going to go sample some events. And those are the 3 events that they sampled. But they were going to do something very different. Instead of going down the pipe quite a ways, they're going to collect the sample right where the gutter discharges to a stormwater inlet. So they did this. They captured 3 storms, as you can see, and they were in 3 different situations. Either the area was unswept, or it just had been swept by a mechanical or a broom machine, or it had been swept by a vacuum. And you can see the results in this analysis are very clear that TSS was reduced as 74% by mechanical broom sweeping, 85% by vacuum sweeping. Their focus was heavy metals, as you can see, and so the metal ranges were impressive. They weren't as high as TSS, but they certainly were impressive. And so when I saw this, I got so excited because I've got a computer model, simplified particulate transport model I wrote 30 years ago, and it was projecting these kinds of reductions. So I wasn't surprised at all, but apparently the rest of the stormwater community was. So let's fast forward to the year 2019. This is the game changer. The University of Florida, in association with the Florida Stormwater Association, involved 12 to 14 Florida MS4s, and they found after a 12-year study of a couple of $1 million for sure, that street sweeping was the best BMP, up to almost 7 times more cost effective than the next BMP for nitrogen and phosphorus recovery. So, what they decided to do is instead of trying to measure stormwater and all the problems associated with that, we're going to measure how much contaminants our practices that we employ pick up. And they looked at sweeping, they looked at catch basin cleaning, they looked at a variety of structural end of the pipe measures. And then they calculated the cost of capturing a pound of nitrogen or a pound of phosphorus, across all of these recovery measures. Sweeping was the lowest cost per pound. Catch basin cleaning was second in all instances. I'm not going to go over it. There's the data for nitrogen. You can see that's a pretty significant difference between number one and number two. And here's the data for phosphorus, which maybe is only a 6.5, 650% more effective instead of, close to 1,000. But let's get right to the point. So the Florida studies found street sweeping to be the most economical and dominant practice that MS4s could implement and optimize in order to maximize nutrient and particulate material PM recovery benefits. And, they came to this conclusion, and yet they did not separate the mechanical or the broom from the air data. So that's even more significant. I'm sure they would have seen the air machines were even better than the broom. So, in any case, the bottom line is the study results are statistically defensible at a 95% confidence level when combining all 14 MS4s for PM, TN, and TP. That conclusion has never ever been reached on a comprehensive street sweeping study because of the costs that are involved. So, that being the case, and so you understand why we're so excited about looking into street sweeping, I'd like to once again focus on the project. City of Santa Barbara leading it. It's NOAA funded through a Sea grant. I've got the University of California, Santa Barbara participating. Ranger and I are also involved. And I want to give a special thanks and shout out to Los Angeles Sanitation for their generous coordination, their support, and their willingness to provide us a location where we could safely do this work. And that was the Donald C. Tillman Water Reclamation Plant, in July of this past year. So, okay, so what are the objectives of our testing? Well, overall, the number one objective is how well do street sweepers remove micro and nanoplastics from the gutters of streets where they are known to accumulate. Folks, 90% of the material that accumulates on an urban street is within 2 feet of the gutter. Okay, it's even greater at places where traffic is greater than that. We want to therefore determine whether this removal of the plastics is a function of the speed of the sweeper. So we have two speeds. We also want to know if it's a function of the different types of sweeper. So we have the mechanical, or what we has referred to as a broom sweeper, but don't confuse that with gutter brooms, because all good sweepers have gutter brooms. So the other two choices are regenerative air or vacuum. And we want to see these. Okay, what about all these technologies operating at the same speed? And then, of course, most importantly, we want to know, how does the plastic that we've incorporated into our test, how well is it removed? And the last one is the fact that we do have a nano-sized version and a micro-sized version of the polystyrene. And so we want to evaluate that. So, here are the plastics, and in the right corner of each of these photos, the source of the plastic. We'll talk a little bit about how they created this, but you can see the microscopic view of the plastics. There's 5 different plastics involved. Later, we're going to show a video. I keep saying there's 6. That's an error. And then, of course, on the lower right, we have some simulant in the mason jar. So, okay, let's talk about the methodology. How did we do this? Okay, first off, we need a clean track. Initially, before the first test, we cleaned it with a street sweeper and then blew it with a leaf blower. Subsequently to every test, we did not bring in a sweep sweeper, clean it. We didn't, we had just vacuumed it. So we basically used the leaf blower. Now, what we do is we dispense a known quantity of material. Turns out we ended up with about 6 pounds, or 634 pounds per curb mile, of artificial street dirt that was been created by the University of California at Santa Barbara, that has been spiked with microplastics that have been placed in a 50-foot by 2-foot wide test track by sprinkling it on hand directly from the jar. If you look at the photograph in the lower left, you'll see that is occurring. Now, this is a departure from the protocol that I established almost 30 years ago, in that I always used a fertilizer spreader to put it down. Now, the reason we went away from this is because we were concerned about the plastics getting gummed up in the mechanism of the fertilizer spreader. Once that is done and everything's prepared, second photo, then we can tuck a single pass of a sweeper at a targeted speed. I say a targeted speed. We've actually worked with this operator. We've given them a couple opportunities to get the timing right, with not necessarily sweeping the curb, if you will. But when it actually occurs, I'm using a stopwatch, and I know exactly how fast they're going. In addition to that, we're monitoring air quality, and believe it or not, we're also monitoring sound, which I haven't even put this in the graphic. After that's all done, so that third thing is the sweeper ready to sweep. After that's all done, then we vacuum the remaining material, including the microplastics left on the test track, using a stainless steel shop vac with a plastic hose and attachment called a gulper. And by the way, we had some concerns about this as to whether it was going to contaminate our samples. And the university conducted some tests previous to because they had the equipment, and they concluded that wasn't the process. Then, of course, the university will process the samples. We'll talk a little bit more about that later. Next slide, that is. So what they want to do, and this, by the way, this analysis is underway. I don't have any data I can share with you on particle size or plastics. I do have some mass data that we can talk about. The first thing they're doing is they're recovering this simulant. They're sieving it into 5 fractions, and then they're going to examine it via microscope and count how many plastics are left in each of the sieve fractions. That's very labor intensive. It's very tedious, but it turns out, as you'll see in a minute, that it looks like it's going to be pretty accurate. Then, once we have that, we're going to compare that to the known quantities, because they know exactly to the number of how many plastics they put in, and where they were associated in terms of size. And then, of course, with all of this data, then we'll be able to evaluate whether speed is an issue and how the different types of machines did. And of course, once they do their work, the University of California, Santa Barbara, they're going to recombine each one back into the original 14 samples that we got, remaining samples, and send those off to a commercial lab for a full stack sieve analysis. And then we'll also send 3 samples of the unspiked simulant to get an idea of what the actual before condition was, how much they put down in terms of particle size distribution. So this is a quick slide to let you know that we used Los Angeles Sanitation's recipe that was designed with my collaboration by Larry Walker and Associates a couple of years ago. There's a presentation on that at this very event. And we got their material that they created their simulant from. We had to augment it with one other thing. Basically, I think I say there's 6, I think there's 7 ingredients to this instead. But anyways, we have no standard methods for microplastics. How we put microplastics into manufactured street dirt. So they had to come up with that. The university had to come up with that. They did an extensive literature review. They collected street dirt in the city of Santa Barbara and analyzed it. And by the way, they ended up shredding that material that you saw in that previous graphic using a coffee grinder and to get it to the right size. And then they tediously put in the exact number of plastics in each of the size fractions that they determined through the literature and through their own work locally. So, when you're establishing a new methodology, you have to have some level of confidence that it's working. So they did a spike recovery analysis. In other words, they created this and then they decided, I'm going to determine whether we can count all the plastics we put in there and make a determination of how much they recovered. And that's what this graphic is showing us. 3 different particle size distributions and what the recovery percentage. Even the lowest percentage was 70%. And what's really interesting is if you look at the research, the data on real street dirt, we're not finding very many microplastics in the finest portions of the street dirt, which is completely reverse from other pollutants, metals, toxics that we have been looking at, and nutrients that we've been looking at and associated with street dirt. There it is at a summary. Put the material down, sweep it. That's actually LA's broom bear, and then pick it back up. 6 sweepers, 5 operators, 3 types of machines, 2 speeds, no waiting. And here's a summary of the results, a box and whisker plot of the results. You can see the range of the pickup in terms of mass only was 63 to 98%. We had multiple operators. Notice there are quite a bit of variation in for the sweeper speed at 10, and then for the 2 of the sweeper types, mechanical and regenerative. And you say, why is that happening? Look how tight the vacuum is. Well, that is happening because of operator error and machine age. I'm going to talk a little bit about this. Like I said before, I've got no information on size fractions and microplastics, but that's coming. So anyways, here's a table of all of the data that I wanted to summarize for you for this presentation. We did 14 tests. We wanted 4 tests a day. And we have the sweeper model and type noted. We have the targeted speed, 5 or 10 miles per hour, but we have the actual speed. So you can see that, some of them were having difficulty hitting, especially the 5 miles per hour, which really begs the fact, why don't we have an odometer and a street sweeper that can be accurate at such a low level? I mean, that's where we should be sweeping, as most of you probably know. Any case, that's how much material we put down the column, and then that's what we sucked up, the vacuumed up. Now, I've got a comment section, and I've highlighted some of these comments because I want to discuss them briefly before Ranger is going to show you a video of this entire operation. And then he's going to present a few things on that are in addition to. Anyways, what is a full gulper width? Remember I mentioned the gulper is the attachment at the end of the hose that we're using to pick up the remaining material. Well, that gulper is about 6 inches wide. And one of the things Ranger noticed, by the way, and pointed out or morning of the second day, is that he thinks that we're not getting as much of the remaining material as we could if we reduce the width of the gulper. So we made a command decision and we reduced the width of the gulper to about 1/3 of what it was before. And so that's why when I say reduce gulper width, everything else, all the other tests, unfortunately, we could not do it for the 2 machines that we saw previously, but we'll have to make some sort of adjustment in their pickup performance to result on the fact that it did make anywhere from a 2.5 to a 4% error. I did not think it would be that great, and I was proven that wasn't the case. The other thing is, I mentioned the wide variation. Why was that happening? It's operator error. See test number 2, the sweep right mechanical. For whatever reason, the operator did not turn on the water. We are using water. That's pretty standard practice. In the past, we've never used it very often, but we realized we need to do this now. So they didn't even turn their water on, and so that demonstrates why that is such a low. I mean, you would say, wait a minute, doesn't water, stop the look pickup process? That's what we've seen in the past in very humid conditions. But when we're in arid conditions, it looks like it goes the other way. And the water actually seems to assist in that pickup process. See, you do these studies, you learn something new. Okay, what else is there? Okay, test number 4. Um, Unfortunately, the operator wasn't really a seasoned operator. He was more the owner of the company, and unfortunately, his gutter broom was completely off the gutter for about 1/3 of the way. And the reason I know that is because we recorded every single one of these, and I was be able to go back and look at the tape and say, yeah, about 16 feet, the gutter broom is completely off of the gutter. So that's a problem. In other words, that's why the number most likely is so low. And then the last, excuse me, number 8, the LA, for some reason, well, we know the reason, but anyways, for whatever reason, the main broom was turned off and didn't function. But remember, we're estimating how much of this material is removed from the curb line, so that didn't seem to affect its performance. And then, of course, the Ravo number 9, this machine is designed to sweep with or without water. You're going to actually see it in the video. And when the 5-mile-an-hour tests, the operator made a decision to reduce the water used, and that was not the right choice. But in the 10-mile test, he replicated that. And that along the way, we lost one of our sweepers. We thought we had a last sweeper coming in on Friday morning. That didn't happen. So we knew this at this point in time. So we decided on that day we're going to redo the Ravo 5-mile and give the operator another shot at it with the full water use. And sure enough, that's test number 11 is a redo of 9, and you can see it did a very nice job. And then, of course, on the last day, since we didn't have a sweeper, this would be Friday morning, so we're going to be done early. But we brought that broom bear back because it's the city of Los Angeles broom bear, and we reran the same test and noticed the results were almost identical because we were measuring the only area that we were sweeping up was the 100 square feet of the curb, not necessarily what was maybe thrown out into the track. And that's just the situation that we ended up with. So, okay, at this point in time, I'm going to stop my share, and Ranger's going to share with you a video that we thought you might enjoy.
All right. Yes, be glad to do that. And one comment that I have on the broom bear, when he ran the test without having the main broom operating, what happened was the curb broom, gutter broom, moved all the debris into the path, or most all of it into the path of the main broom, and then it just was smeared along the part that we didn't vacuum up. So that's why it showed the same amount about taken out of the gutter, but that was just left on the pavement. Of course, that's not a good situation. So here we go with the video that we did. We did one of these pretty much with each of our machines for the people that were involved in this, and
Testing it.
here we go. So here's day 4 of our test process and day 3 of the actual sweeper testing. It took all day the first day to get ready for the testing process, and you can maybe talk about that even, Roger. But this is Roger Sutherland, who's the most noted sweeper tester in the country, probably the world, who's here co-leading this testing process with myself and through the city of Santa Barbara. And so, Roger, what do you think about it so far? What do you want to say?
Okay, well, first, I appreciate the opportunity. We're going to have an airplane go over in a minute.
That's right. We have a lot of them. We're in a jetway.
We're at a wastewater treatment plant in Van Nuys, California, graciously provided to us by the city of Los Angeles, because we need a location where we don't have to worry about traffic, and we can basically perform a controlled pickup performance test for a street sweeper. Now, the focus of
I'll
this
run down to the track. This is the test track.
The focus for this research is foremost microplastics. Microplastics has been a growing concern in the environment, especially because of its accumulation in the oceans and what effect that can have on those aquatic species. And so what we're trying to do is make the determination as to whether or not street sweeping as a standard practice can be effective in removing microplastics that we have found exist in abundance in what we affectionately call street dirt. Street dirt is the material that accumulates on the street, usually up against a curb. If you don't have a curb, you notice that you probably don't have any street dirt. So you have to have a barrier of some type, New Jersey barrier curb. So this material is contaminated. We've been looking at it since 1969, or really 72-ish. And we know it's contaminated, so that's been our focus. And what we've done here, and this will be the 6th time that I've actually conducted controlled pickup performance tests with street sweepers, we've put together a simulant. We're trying to mimic what the particle size, distribution, and specific gravity of street dirt looks like, at least the dirt fraction of it. We don't put any leaves, any organics, although that exists in nature. This material is easily picked up by street sweepers. It's not even an issue. As long as the accumulation isn't massive, it's going to pick it up. So basically, we have a simulant of 6 different silica products. Each has a little particle size distribution. Put together, we get street dirt. And this street dirt probably has about 10% of the material is less than 63 microns, which would have a lot of contaminants if it were real street dirt, but it's inert. In addition to this, the University of California at Santa Barbara has been researching microplastics in the environment, and specifically now in street dirt, and they know what type of microplastics do exist. And so they have been tasked with spiking the simulant with the appropriate number, concentration, and type of microplastics. We have 6 different types of microplastics. The only one I really know of or ever heard about quite a bit about was tire particles, rubber wear. But in any case, I can't speak to that, but I can tell you that this has never been done anywhere in the world as far as I know. So what we're doing is we're putting this material down. We're getting a street sweeper. We've got 6 different street sweeper models.
And let me break in here as a cameraman ranger at World Sweeper. Say, for example, to give a couple other examples of the microplastics in there, they've been made to be very tiny by a PhD, Dr. Lee, of the University of California, Santa Barbara. Pieces of blue tarp, and very tiny, is one of those. Pieces of string trimmer, I know, is another one. And some fibers from clothing type, which is something that's also very pervasive. So there are 4 of the 6 anyway.
Yeah,
so
thank
go
you,
ahead.
Ranger. That's very helpful. So basically the process is we get a street sweeper here, we work with the operator, we get him comfortable. We have 2 test tracks that we have laid out. The first day, we spent most of the day caulking the gap. There's quite a large gap between where the concrete apron is and the asphalt pavement. On that side, it's more pronounced and it's deeper. And I did not want that to be a problem, because if material gets into that gap, it's very difficult for even an air machine, even a regenerative air or a vacuum machine, to remove it. So I wanted it to be a fair test. So that has all been caulked. We have 52 50-foot tracks, 2 foot wide. It's the apron where we load, even though the track's on that side. It's just the apron.
This is one of the tracks. From this
10
cone
mile an hour.
and to this cone is the 10-mile-an-hour track.
Oh, our street sweeper
And
has
we
arrived.
have a 5 to 5.
We'll have
mile
to
an
pick
hour.
this up at a later time. Give him a shot of that street sweeper.
All
That's
right.
what we've been waiting for.
The Fayette machine, and today the Ravo machine is going to be tested from Fayette. And they're
Be
here,
able to
so
turn around?
we'll have to go.
All right.
Do you want me to?
I'm documenting that Dr. Lee is putting down this. So we're talking to Matt from Fayette and Bravo in this instance. And Matt, as the operator, you've done a great job hitting your times and all that. And you got a chance to see your 5-mile-an-hour results. What are your changes that you anticipate the sweeper needs for the 10-mile-an-hour test?
Well, first of all, 10 miles an hour, in my opinion, is pretty fast
Of course.
for sweeping. So, really, for this pass, from what I learned from the 5-mile-an-hour pass, we're really just kind of going to crank everything up. I'm going to use more water on my curb brooms, a little higher fan speed. My broom speed is turned up, pretty much maxed out. The idea on this run is going to be to basically get as much broom contact with the concrete as we possibly can, and moving at such a high speed. So with any luck, we'll be able to get all that material moved into the middle of the machine, into the path of the suction nozzle and up into the hopper.
And it's the expectation, but that's why we're testing, is we're going to show that 10 miles an hour is too fast to sweep in this game. So
Yes.
that's what your agreement in coming into this too.
Yes, and normally I see with Bravo specifically being a vacuum machine, you got to give them time to do their job. So usually, even if I'm on a regular, relatively clean area, doing cigarette butts and litter and stuff like that, usually somewhere around 6 miles an hour is probably about as fast as you want to go. Otherwise, the machine's moving too fast for the brooms to do their job. So it'll be interesting to see, cranked up here with what we can do at 10 miles an hour.
Well, let's go see.
We're going to find out.
Ready. This test is of the Bravo machine at 10 miles an hour. About to hit the cone right about now. This is Ranger Kidwell Ross, editor of WorldSweeper.com and the director of the World Sweeping Association. I wanted to let Bravo fans and Fayette fans know about this test that they were just involved in. It was handled by the city of Santa Barbara. Dr. Jill Murray was our lead. She isn't here today. However, we do have a representative of the city of Santa Barbara, which is Lori Vanderhorst, who's here. And this is Matt, who was the capable operator of this Bravo machine today. Roger Sutherland is the most experienced and noted sweeper test designer that there is. I'm a close second, but he is the lead. He's our leader, and we also have Kaylin, who is with the University of California. Is that correct, Santa Barbara? Carlos is a representative from the City of Los Angeles, who we're very grateful to City of Los Angeles for letting us use this facility for our testing. And Dr. Lee is involved in the sifting of the material and coming up with the data that we'll have. We have two tests here. The first national sweeper test in over 25 years. And what we have done is to have a 50-foot test done at 5 miles an hour by this machine, 2 feet of simulant that's non-toxic simulant of street dirt with microplastics in it. The idea of this study is to see whether sweepers can remove microplastics as well as other street dirt, and how well they can do that. And it's turning out they can do it pretty darn well, especially with this machine. We do another test at 10 miles an hour with the same 2-foot wide strip, and this machine was remarkably about the same for both of them, in the 90% removal rate. And so that's what Rabo can do. That's what we're seeing. We want to also acknowledge Professor Patricia Holden, who is also with the University of California, Santa Barbara. She couldn't be with us right now for this photo shoot. She's been very integral in helping us design all of this. And we're much obliged to Sea Grant and NOAA for providing the grant money for this test, and with the overall capable design and management of the city of Santa Barbara, which has been great. So thank you again to Rabo. And yeah, have Roger add a couple items.
I appreciate that, Ranger. Excellent job. And I think it's important for everyone to understand that the simulant that was utilized, the base that was utilized and the microplastics were put into, is made up of 6 silica products. These are inert sand, silts, and even paint pigments. So we can end up in a recipe of a combination of these to end up with what street dirt normally looks like. I've been collecting street dirt since 1980, so I definitely know what it looks like. And the amount of effort and time it took Dr. Lee and Patricia Holden and their assistants to put those microplastics in there. Those are microplastics that have been observed in this contaminated street dirt throughout the world, in addition to their own work locally to confirm that, yeah, these are the we have 6 different types of microplastics that have been placed into this at the appropriate frequency or concentration by particle size. So everything's going to be analyzed, and we're going to have results which will, quite frankly, be the first time ever in the world this has ever been tested. But the overall objective, like Ranger said, is simply, can sweeping as a practice with a wide variety of machines that are well designed, machines that aren't well designed, in a wide variety of conditions, and perhaps a wide variety of operator experience, can that pick up microplastics? And this is so important for us.
We'll have Roger is going to share his screen again, and we'll go through the rest of our presentation. And wanted to show that we also tested air quality. For that, I contacted the South Coast Air Quality Management District, which over a quarter century ago had the last real sweeper test that has made a big difference in terms of what machines were available to be sold in the Southern California region, as I've reported on, and I was at that test also. But every sweeper that tested at that time passed the test. They found a way. It didn't matter, mechanical, air, whatever. They added more, in some cases, I know added more water quality or water dust suppression nozzles and so forth. So they all passed, and that has been an albatross for us ever since. But I did consult with them. We tried to get them involved. We were unsuccessful with that after multiple tries. They cited manpower and funding at this moment. So, but we did get a recommendation for the kind of dust monitor we should use. You see the Dust Track 2 that we use. We rented it for the week, and it's really indicative of what using water for dust suppression really does, because the data shows that one sweeper where he forgot to turn on his water, we had 10 times more dust. So that's exactly what happens, and that's why it's so important if you're out there street sweeping. Make sure that even with the expense that you make sure to keep using water. We also tested the sound level of the different sweepers, and that's something I want to encourage all of you MS4 representatives and stormwater representatives. When you're testing and specifying sweepers, coming up with the one that you want to use, do a sound level test as well. You can get a free app on your smartphone that will test that by decibels. And showing this, you can see that the differences range from 92 dBA to 102 dBA. So you might think, oh, well, that's only 10%. How could it matter? Well, that's a doubling in the dBA system of perceived loudness, and the permissible exposure on a 92 dBA is about 6 hours. At 102, it's only an hour and a half. So when you evaluate your sweeper, be sure to use a decibel app just so you have that information, and it can make a difference for the community and how much noise they're being subjected to as the sweeper goes by. So here are our key takeaways that we want to bring out to this webinar. Uh, it's really important to demand and support independent head-to-head sweeper performance testing. Uh, See what the different manufacturers actually can provide. It's very important to have the right kind of material down. Don't just put down so much material that nobody can pick it up. For example, we know that in the northern tier, when you come out of winter, it can sometimes take a skip loader to pick up your material, and that's not what you're trying to find out about the sweeper. So do the same material put down for all of the sweepers you're going to test, and that's an important part. I wanted to show that we also tested air quality. For that, I contacted the South Coast Air Quality Management District, which over a quarter century ago had the last real sweeper test that has made a big difference in terms of what machines were available to be sold in the Southern California region, as I've reported on, and I was at that test also. But every sweeper that tested at that time passed the test. They found a way. It didn't matter, mechanical, air, whatever. They added more. In some cases, I know added more water quality or water dust suppression nozzles and so forth. So they all passed, and that has been an albatross for us ever since. But I did consult with them. We tried to get them involved. We were unsuccessful with that after multiple tries. They cited manpower and funding at this moment. So, but we did get a recommendation for the kind of dust monitor we should use. You see the Dust Track 2 that we use. We rented it for the week, and it's really indicative of what using water for dust suppression really does, because the data shows that one sweeper where he forgot to turn on his water, we had 10 times more dust. So that's exactly what happens, and that's why it's so important if you're out there street sweeping. Make sure that even with the expense that you make sure to keep using water. We also tested the sound level of the different sweepers, and that's something I want to encourage all of you MS4 representatives and stormwater representatives. When you're testing and specifying sweepers, coming up with the one that you want to use, do a sound level test as well. You can get a free app on your smartphone that will test that by decibels. And showing this, you can see that the differences range from 92 dBA to 102 dBA. So you might think, oh, well, that's only 10%. How could it matter? Well, that's a doubling in the dBA system of perceived loudness, and the permissible exposure on a 92 dBA is about 6 hours. At 102, it's only an hour and a half. So when you evaluate your sweeper, be sure to use a decibel app just so you have that information, and it can make a difference for the community and how much noise they're being subjected to as the sweeper goes by. So here are our key takeaways that we want to bring out to this webinar. It's really important to demand and support independent head-to-head sweeper performance testing. See what the different manufacturers actually can provide. It's very important to have the right kind of material down. Don't just put down so much material that nobody can pick it up. For example, we know that in the northern tier, when you come out of winter, it can sometimes take a skip loader to pick up your material, and that's not what you're trying to find out about the sweeper. So do the same material put down for all of the sweepers you're going to test, and that's an important part. I'll do a sub here to the process of getting these sweepers for our testing. It was onerous. For whatever reason, the manufacturers, with the exception of the largest in the world, Fayette, and SweepRite, which is also out of the United States. They are based in Canada, although now have a factory in the United States, and they are in the process of they are in the process of doing a. I'm going to start that over, Roger. I'll find this. So one of the things I want to talk about is the use of the sweepers that we had for this test. One of the things that occurred is that we could not get sweeper manufacturers, with the exception of Fayette, which is located in the Netherlands, is the largest sweeper manufacturer in the world and markets into the United States, as well as SweepRite, which is Canadian, and they were very confident in their machines as well. They now also have a U.S. manufacturing facility, and none of the other manufacturers would supply a sweeper. They were not interested in doing that, and I can only assume they didn't want you to know who had a better performance pickup. So we had to procure these representative machines from sold in the United States. We've had a contractor provide us Schwartz. We could only get an old machine in their entry level A4000 because Schwartz would refuse to participate. Elgin did not want to participate, and we used the Los Angeles city machine from that. So there you have recognition about the operator experience. You're really seeing what that means in these testing. Make sure your operators are well trained and can really recognize when they go over a particular type of material on particular types of streets, how they should operate their sweeper, what gets them the best amount of pickup. And we want to encourage sweeper manufacturers to take part in testing, and you can do that. As MS4s, when you are looking for a new sweeper or sweepers, be sure to do good testing on that. The other thing we're talking about is financial incentive programs. These are very important. It's happening in Florida and some other places where the cities are gaining credits for their stormwater programs and against their requirements to pick up material. So TSS and MTL and so forth. So see if you can't get that to happen. And the last one is educating the stormwater community is really a pathway to cleaner streets. They have, in some cases, a better budget to be able to get involved, and they can augment the sweepers that are purchased. So let's get our oceans more clean. So to finish this, I want to recap to what can happen to your sweeping program. And this is the part that if you have seen a previous presentation or information I've provided at World Sweeper, Earth's largest power sweeping resource, then you can leave the seminar now. But otherwise, if you haven't put together an enhanced sweeping program, listen to this. It's very important, and it's exciting about what you can do now. The most important aspect is to remove the cars before you sweep. That's the only way you're going to really get good control of how much material is picked up. Fortunately, as it says in the second bullet, using now available technology for citizen notifications and updates is available. You can put together an app that does that for you. Instead of having a signs up that say they have to move their sweepers for 4 hours or their vehicles for 4 hours, instead you can have them in today's technology just log on, put in their address. They find out how they can get notified when the sweeper's coming. For example, you'd have a pull down that says, "Tell me when it's coming tomorrow." Now you have another one that says, "Well, tell me also when it's an hour or a mile away." And that allows people to leave their cars in place and then move them while the sweeper goes by, and then they get another notification that shows that the sweeper has passed, and from that they can put their car right back in. How do you ticket them? Well, you can put a camera on the front of the sweeper, and that can take pictures of license plates. Those license plates can be transmitted to the ticketing facility. It will solve your manpower problem of having what are long called meter maids come along behind at some time behind the sweeper, um, and it really saves with doing that. Now, using the right kind of technology, very important. In the general city street sweeping, you do not need a broom sweeper. You need to use air sweepers, regenerative air and vacuum sweepers. It's just is better and uh, better to do. Now, optimizing your sweeping frequency, adjust the frequency based on what you want to be doing in that area. Do you have runoff to waterways? Do you not? You want more frequent sweeping in high accumulation areas and so forth. Obviously, if you swept once a year, you're going to have a huge amount of pickup. If you swept once a day, you'd have almost nothing, but you'd have the same cost basically of the sweeping. So figure out where your best spot is, sweet spot in the middle of how often you should be sweeping in your different routes. Pavement condition, huge indicator of how well a sweeper can do. The material can stay down in those cracks. So you also want to focus on your curb streets. That's where the material goes up against the curb and you'll get a chance to pick it up. Obviously, you have to pick up the large material on highways and so forth. And that's where broom sweepers come in, as well as construction sites and those sorts of things that really need it. But get the cracks in your poor pavements, get those sealed. Monitor the kind of material you're picking up. Why not keep track of what the sweeper can do? And you can find out by sampling what kind of pollutants are in the material that's coming off your streets. So then you'll know how much material, how much pollutants you're picking up. Rogers talked about his simplified model. It's great to tell you exactly how much material you might expect for wash off. It can go back and see your rainfall rates across the board and historically, and it will tell you what to expect by sweeping, and that's great. Now you have data-driven insights to where you can allocate your resources. I've long recommended that you add your sweeping program to the stormwater department, and that way they in many cases have a larger budget these days, and by combining that, you're fighting your stormwater issues, your stormwater pollutant issues together, and you can combine your budgets. You don't have any kind of infighting, and you can have better analysis, be better analysis equipped as well. Another thing is about sweeping, because it's onerous for people to move their cars, and it's very important you make sure they do that. But now we can, as I said, we can make it easy for that. Educate your citizens about the value of sweeping, what we're doing here. We're improving our environment in significant ways. We recommend putting hopper graphics if you have a big billboard on the side of your sweeper, so use that up. And it's great to have some of those graphics go down into, say, the 5th grade level or something like that. Have a contest for graphics, education, teach those kids to tell their parents what's really going on, and that's a value too, through school education programs and so forth. Now, and the 10, outfitting sweepers with data collection systems for community. What that means also is there is technology out there that has been tested and works, that you can put another camera, maybe even combine them these days, but I think you'd have to have a secondary camera. And that can, through AI, can notice when you have overhanging branches, when you have signs that are down, when you have um, pavement that is having potholes emerge. Those can take photos of that. They'll take a GPS stamp. They'll send it to the appropriate department to fix that. Now you get done earlier than you might otherwise. Your ticketing system, this camera-based ticketing is just great. It costs you less. It's more effective. It just can't be um, the person who's had the ticket done by the sweeper's photo. There's no contesting it, and that also allows people to park right after the sweeper goes by. So that's great. Now, in terms of regulatory alignment, work toward what places like Florida has done, where you have state level regulations that give you credits for the amount of pollutant you've taken off your streets and out of your environment, and get credited for that. It is something that would work well, and it's a real incentive to sweep more for sure. And of course, things are moving pretty fast these days. Stay informed about whatever the new technologies can bring you from AI onward, and what your best practices are, and then participate in or follow the results of whatever kind of research and testing you might get involved in. We are the largest information resource for street sweeping on the planet, and I put the address you can go to see all of the different categories that we can go into there at the bottom. And if you ever have questions, Roger and I are both, we're both born in 1950, and combined we have about 100 years of experience with street sweeping. And you need to get us while we're still around on the planet and ready to help, and we are still. So that concludes my side of the presentation.
Thanks, Ranger. I think you did a wonderful job, and I'm so excited that we're once again have the opportunity with sharing the knowledge we've gathered throughout our lifetimes with everyone that has a similar interest.
So if you have questions, be sure to get hold of us. And until then, good sweeping.